Thank you all for joining URLLC, A View from the Edge, How Edge Computing Enables Ultra-Low Latency Applications in Vertical Markets. My name is Mona Ashur, and this webinar is brought to you by Sensafili in collaboration with EIE, the organizer of 5G URLLC 2018 conference, taking place in London on September 5th and 6th. As time permits, all questions will be answered at the end of this webinar. Also, please note that the slides will be shared after the webinar. To begin, I would like to introduce today's speakers: Monica Paolini, Principal of Sensafili; Milan Lalovic, Principal Researcher, Wireless and Network Services, BT TSO. Dan Chen with China Unicom was not able to join us today, unfortunately. Monica, please begin.
Thanks for calling in, and it's a pleasure to be here and talk about URLLC. In my presentation today, I will talk about URLLC in the context of edge computing. And while I'm doing so, it will become clear through the course of the presentation, but let me get started here. I've been doing a lot of work on both latency and edge computing, and URLLC recently. It's a very hot topic because it's something very new that we are asking mobile networks and wireless networks to do. Typically, in a mobile network, you understand there is latency. Is something that you try to manage the best you can, but we have never done in the industry something where latency and reliability are crucial both at the same time. So I will talk about that and then talk about why is edge computing relevant here. So let me get started with the top level view, and then Milan will provide the viewpoint from an operator point of view. So in 3GPP, there are three use cases. There is enhanced mobile broadband, the massive machine type communications, and the ultra reliable low latency communications. Now, URLLC includes also a lot of massive machine type communications as well, but it's a subset of those, and there are applications that are not MMTC. So it's a little bit of both, but the requirements are to some extent different. And so in terms of the key requirements is that you need to have high reliability and very low latency. So 5 nines to 9 nines of reliability, sub-second to below 1 millisecond of latency. And that depends on the application. But one thing to keep in mind is to have both of them as requirements at the same time is particularly challenging. So if you only need to lower the latency, it's hard, but it's easier than lowering latency and reliability, because oftentimes to increase the reliability, what you do, you put a lot of checks in the process, and that creates an overhead that impacts the latency in a negative way. So it's very difficult to combine both reliability and latency, because you usually are willing to pay a price in latency to have a system more reliable. So that is a challenge. And the work on 5G from a standards point of view it's really focusing on that. And that's really crucial, because you do need to have an interface that accommodates for that. But my argument is that we need it, but in order to take advantage of that low latency, you also need to have, you need to do other things into the network, and edge computing is one of them. So I will get into that later. So first of all, let's just talk about where does it matter, what applications, and here are some of them. I'm not going to spend any time going into the specifics here, but one thing to keep in mind is that there are different requirements that vary. The latency is different, reliability, the throughput, the security. So for instance, if you have virtual reality, for instance, in a sort of a consumer environment. Well, security is still important, but it's not as important as it is for, say, autonomous driving. At the same time, security might be more more important. Throughput might be more important for virtual reality, but less so for other applications. For instance, for control, for remote control, when you're controlling a machine where you need very little information to go through. There is, you know, URLLC is not just one type, one set of requirements that are needed for all the applications. And then there are some like gaming where you might need to have low latency for some part of the applications, but not all of it. So the video doesn't have to be at the very, so this is the commands that need to be at a very low latency, but some of the visual information doesn't need to. So it's a little bit more complicated, and it's not just one set of requirements. Now, latency is one of the requirements, and we talked about reliability as well, but I'm going to focus on latency and in my presentation today. So the lower latency that you have in a 5G RAN, it's good for URLLC, but also it's also good because for real-time traffic and latency sensitive applications more generally. So what that means is that latency is becoming more prominent. And the Telefonica CTO a few years ago said that latency is becoming just as important as throughput. And this is really, it's important because it used to be that latency was something that you do your best, and most of the focus in terms of performance was on throughput. But low latency, from a user perspective, oftentimes a high latency looks like a slow network. So they're both equally important, and it's important that they play together because some applications need low latency, some need high throughput, and you need to balance the two. And so latency has a huge impact on how the service is perceived, how the network resources are used. And now we have better ways to manage latency and to extract value, revenues from it. And so this is quite important, and it adds a new dimension in the way you manage the network, because you can manage latency for different services and applications differently. And so this is crucial in terms of URLLC, in terms of enabling it, because you need to put it in the wider context of what the network is doing, because it's not just very low latency applications. It's the network has to support all of them. So the question is how to balance them, how to balance the trade-offs. So, step number one is that you want to make sure you enable those applications. But step number two is to make sure that you enable them within a wider context of coexistence with other applications. And this is because lowering latency is expensive. So you can have low latency, but it doesn't come for free. And so you need to make sure that you lower the latency where needed, but not across the board. So managing latency does not mean that you're necessarily minimizing it across the board. You only want to minimize it where that adds value and where it's needed. Because this way, if you are allowing, in some cases, so if you have, for instance, you are downloading a big file, you don't need to get very low latency there, and then you can use the network resources more efficiently, because you basically send the file whenever you don't have some other traffic flow that requires higher latency. So the higher latency for some application improves network utilization. So you need to manage latency at the service level. And that's where you can increase the network efficiency and lower the cost. And at the same time, you can enable new services and charge for them in terms of, so for instance, if you're supporting a service that requires low latency, you can charge for that if you can meet that requirement in the same way that you do for capacity. So we need to see URLLC in the wider context. So now the good news is that latency doesn't matter everywhere. So this is actually the fact that you can manage latency. It's very useful because for most applications, latency, it does matter, but not as much. And if you see here, this is a nice slide, and there are different versions of it. But basically what they all show is the delay and the throughput in the two axes. As you can see, there's only a few applications that really require high, very extremely low latency and a high throughput. So what you want to do is to make sure that those applications have the low latency, but the other ones you have more flexibility, and depending on where they are, you have different degrees of flexibility. And so even if especially here, if you look at, like, for instance, video streaming, oftentimes we think of it as a low latency, a low latency type of service, but it really isn't, because you can do a lot of buffering. So so video is sensitive to latency, but at the same time, there are ways to work around it so you don't need an extremely low RAN latency. But then if you go into video calls, it's still video, but then you have much tougher, stricter requirements in terms of latency. Now, when we talk about latency, and important to keep it low, we need to, there are different things that we need to take into account, different sources of latency. So the RAN latency with 5G can be very low. Doesn't mean that it's going to be extremely low everywhere across the network. It's going to be lower than 4G, but to sort of maintain that kind of latency, extremely low latency, like the 1 millisecond latency across the network, it's just going to be extremely expensive. So you need to, again, focus it on where you need it. But in general, there is clearly a trend that you can see here in terms of latency and throughput from 2G to 5G. But 4G is actually pretty good in terms of latency. You can get up to 10 millisecond latency in the RAN. So it's not bad at all. But when you consider latency, we need to keep in mind that distance creates latency, and that's unavoidable. So if all the processing for the URLLC application you're using is done remotely, as at a high distance, well, that is going to have an impact on latency. So no matter how low the RAN latency is, you still have a latency. And that's where you do need to move content and functions to the edge so that you can control latency. You basically do not have to deal with the latency created by distance, and you can mitigate the impact of it. And that's a very effective way of doing it. And you need to do it for some of the applications, especially where you do need to have a very low latency. So here at the bottom, you can see that, so you have, well, first of all, the human, we do have a latency if if there is a human, and now with URLLC, typically that's not. So that part is somewhat, that part is gone, but the device, the mobile device or the terminal in an IoT application also has some, introduces some latency. Then there is the RAN latency. And then you have all the backhaul and core and transport latency that it's within the network. But then if you go into the cloud and you go into the internet, that's another source of latency that it's even more difficult to control. So by moving everything closer to the device, to the terminal, you do have better control and you can lower the latency. And there are also other aspects as well. Now, why do we need edge computing in general? The main driver is latency, but also it allows you to have more capacity. You can deal with local content, local processing. And for a lot of URLLC applications, that's valuable because You can also have a security control. So there is a lot of benefits, especially for enterprises running enterprises, or for whoever is running the service or using the service. And so, and that also translates into a lot of benefits in terms of network utilization, performance, cost savings, and the ability to roll out new services. So it's more than just pushing the infrastructure to the users. It really makes location aware, where things are in the network in a new way, where, in traditional networks, like in today's networks, everything it's centralized is in the core or it's in the RAN. So you have the two of them. And in fact, here, if you think about how we did to the edge, there's been a little bit of a swing here. So right now, so the traditional network is a centralized core and a distributed RAN and separated with each other. Then with cloud and virtualization, things started to become a little bit more flexible. And now with edge network and slicing, we have a trend towards moving more of the more of the function and the processing to the end. And what this is at the end, what this is going to we need to recognize that we need both. And but that location where you put things is crucial in terms of enabling applications and enabling them in a cost-effective way. Now, in terms of there are other technologies that strengthen edge computing, and also URLLC benefits from them. So it's edge computing, but in terms of the overall network and beyond the RAN, clearly there are other technologies such as virtualization, cloud RAN, network slicing, and the orchestration, which are basically all part of a network transformation in which the networks are more adaptive. You can manage services in a more granular way. You can work in real time, and so all of this is somewhat indirectly, but in a fundamental way, enable all the applications that then require the low latency, because you create an infrastructure that is able to support different latencies for different services. And this is what you need in order to make sure that you can support those services. So it's more, I guess what I'm saying here, it's more than having low latency in the RAN. That's necessary but not sufficient. Now, where is the edge for URL applications? So, I talked about where is it, about the need to move things towards the edge, but there is really no edge. There is no single edge. There are multiple locations. So depending on what you want to do, you want to move closer to the user or to the terminal, or farther away. And there is a trade-off, because the closer to the edge, the more expensive it is typically, and the more difficult it is to support things like mobility. So you want to be as close as you need to, but not too close. So, and in fact, ideally, you don't want to be close to the edge at all if you can avoid it. If you can have everything centralized and there is no benefit, then you don't want to go to the edge. So you need to go as close to the edge as you have to, but not too much, because there are a lot of trade-offs. So it really depends on what you want to do. So in a network where you do have multiple applications running in a concurrent fashion, you're probably going to have different edges. And where those are, to some extent, it's still, we're still learning. So we know that there's going to be different ones, and depending on what you're trying to do, depending on what your network is, the answer might be different for different applications, for different operators, for different enterprises, if it's the enterprise running it. So to conclude here, so edge computing gives us a new way to think of location. So as I said before, it's not just pushing content and function closer to the subscribers and the connected devices, but it's allowing us, or the operator in this case, to decide where where functionality and processing and content should be located. And that depends on what you're trying to do, what services on your network. And so there are multiple edges. They're shifted dynamically in time. And so that's a challenge, because we have to figure out where things go, but it's also a great opportunity because it allows us to offer services like URLLC, which really require a very close, a very granular monitoring of latency. Now, the centralized versus distributed dichotomy in this context ceases to exist because you need both. The question is how much of each you're going to need, and you know, how do you want to approach it? And to a great extent, that becomes a strategic choice that depends on performance, on the value, what is that you're trying to do with your network. And it's also a differentiator because different networks might have different capabilities. Or if you think about a private network, you know, that can, you have the flexibility to create that and to set it up as needed. And in all this, edge computing is a crucial enabler of URLLC because it makes it possible to benefit from the low RAN latency in 5G. The risk is that without edge computing, you have all this, you know, perfectly low latency in the RAN, and then you have all these other contribution to latency that basically destroy it. So, or that you not that they destroy it, you just don't have the right latency for what you're trying to do. So you need this, and also there is a local processing and content for a lot of applications. Is quite it's important, or it might even be necessary. And sometimes if you think about some enterprise application, security might also be an issue. So there is all sorts of reason there's all sorts of advantages in addition to latency to have an edge computing component to most of these applications. So this is all for me. So I would like to hand it off to Milan, who will give us more detail on how BT is going about this.
Okay. Good afternoon, everyone. I hope you can hear me well. Welcome to this part of the session of the webinar. My name is Milan Lalovic. I work in BT in applied research at BT Industrial Park. My background is networks related, so I apologize if some slides are a bit more technical, but hopefully if you have any questions, I will come back to you. Please do ask. I will start my presentation with a good starting point in any story. It's understanding requirements for ultra-reliable low latency communications. Monica already presented a very similar slide. This is just another view on an umbrella of 5G services in which mission critical machine communications comes as one important section that requires low latency and ultra-reliable network. Of course, as Monica already mentioned, you know, there's always trade-offs between other parameters such as coverage, capacity, spectrum, availability, number of devices, and so on. And they all have effect on the end performance of the device. But at least we understand that for the mission-critical machine communications, such as autonomous drones flying or remote surgery, applications like that, latency is on a paramount importance. Now, as this part of the section, section of the webinar is a network perspective on edge cloud. Very quickly, again, I just want to touch on what edge cloud compute is. And with this, in today's world, the application logic, i.e. the brains of the services, typically resides either in a telco provided data center or in enterprise or public clouds. And that's okay for applications that are supported like voice traffic or internet data traffic. In all cases, the logic is far away from the end user in relative terms, and the latency is what it is. However, with the emergence of the 5G services and applications, and especially for the ultra-reliable low latency, we will require a wider choice of network locations for their logic, either due to the latency requirements, such as case, for example, in a V2X, when the car need to talk with the infrastructure, that has to be really fast. So you don't have much choice but to place edge cloud very close to the transmitters. Or, for example, for the video surveillance in important sport events, latency is important, but not that important for service to work. So it makes sense to put application servers somewhere which might be a bit more network economics oriented decision where to put it. In either case, the edge cloud compute is development of multi-purpose hardware resources at the edge of the telco's operator network in order to flexibly route traffic following the most optimal network path. And this optimal means either satisfying low latency requirements for mission critical applications or driven by pure network economics. Now, the key enablers for edge cloud compute in a telco network comes in 2 or 3 fundamentally new capabilities in our network. This is flexible allocation of user plane functions is a key to edge cloud, and in terms of 4G, that could be either breaking S1 interface or distributed S gateway, or in 5G, that's distributed UPF function. Of course, orchestration of these network functions that are virtualized and placed on edge nodes is important, and again, emerging or new capabilities for telco operators. They may have that in a big data centers, but this is now, we are talking about expanding this to the edge of the network. Another aspect is, which is very important, especially for 5G services, is convergence between fixed and mobile network. In many cases, placing edge node in a strategic location that can serve both fixed access and mobile access makes not just commercial, driving a cost down way of deploying edge node, but it also may be required. Many applications might need both fixed and mobile access. How it is this done, it's not new. Data networks and data centers has been for many years in place, and we are talking about just a small scale data center at the edge, which is using a standard servers with Intel or ARM based compute nodes with OpenStack virtualization on the top of which you deploy network function as a software modules that can be deployed, removed in a dynamic way. The way how orchestration is then done, it's through distributed cloud technology, just expanding whatever orchestration is done in a centralized data centers need to reach edge of the network. Now, next couple of slides are a bit historic and a bit providing a bit background, what is important for the network operator when it comes to thinking ahead. And if you want to have industrial strength solution for edge computing, first thing we need to look at is what standards are available, that will help us create environment. And for network operator, we would like to have healthy environment with multiple vendors that they have a healthy competition there in order to reduce the cost. Now this is where the things become a bit complicated and complex, because historically, big giants like Amazon or Cisco, they are already in a edge cloud is not new for them. You know, they have a huge market that they develop, like Amazon, AWS, and Greengrass core architecture. It's been there for years, and they have a huge audience and a number of people using IoT-based services. However, they're not really interested in a at that time when they're developing their market into standards. Nowadays is coming when they do want to integrate their services, not just to be OTT service, but they want to bring it a bit closer with the especially mobile network operators. Fog architecture and Cisco is similar economic positions. Looking ahead, 3GPP standards are coming. CAPS architecture, this is control user plane function separation is fairly new standard from last year, and UPF and 5G architecture in release 15 and 16, we're expecting that to arrive this year and 2020. So where we are in the last couple of years, we are somewhere in between. And companies, a number of companies and great individuals made great effort through, for example, ETSI MEC standard to try to put some umbrella for edge cloud compute, which even by name, MEC means multi-access edge computing. They're trying to somehow put together fixed and mobile environment and provide architecture that will help not just network operator, but it will help application developers as well by providing platform APIs. Those APIs are very important, as I said, for network operator and for the application developers. Historically, there are other initiatives that I only mentioned here, M-Core, there is Open Edge Compute and many others, so the environment is fairly complex. But in this case, I use ETSI MEC as example, not converging, but one of the standards that maybe are anchoring all other initiatives. If I superimpose ETSI MEC, they created set of 6 APIs at the moment they have published that will help onboarding VNFs. It can provide APIs such as radio network information, so application developer can tap into network and maybe develop some new and innovative applications and so on. But other companies realize that there is a bit of gap in this API, so they focus on service-oriented and device-oriented APIs, and this is open edge computing initiatives that even try to commercialize this through a company called Mobile Edge X. If anyone is following that story, it's very interesting. So they're focusing on that aspects of providing APIs. Other giant or great effort initiatives that are coming from core. So we're having mobile core, M-Core, residential core, enterprise core variants that are looking into OpenStack and Kubernetes and so on. But these APIs are more from, coming from the bit lower network specific APIs that will support network operators like BT, maybe to integrate this into orchestration and so on. 3GPP is having contacts with ETSI MEC, and they're having, it is early days to my understanding, but they do have some sort of coordination efforts with ETSI MEC. And then you have, as I mentioned, Amazon and Fog who are such a giants that they have their own markets. When it comes to deploying edge node, and this is could be a bit more technical, I apologize for this. There is another question is how you actually offload the traffic. There is a function that, for example, again, in ETSI MEC architecture, and there are many other architectures, it's called traffic offload function. This standard does not specify how it's that done. So it's open to vendors to implement that. BT is playing very active role through a project called Telecom Infra project, and I suggest people, if you didn't hear about this project, please read it because there's a lot of interesting work. BT is supporting 2 use cases here, investigating or working with vendors and trying to. Our main goal through Infra project is to support edge cloud ecosystem. So we are having early adopters. We want to see what technology can do, and invite application developers to onboard their applications so we can demonstrate capabilities of the cloud, of the edge cloud. For example, traffic offload function that is very close to the edge of the network, it's called S1 bump in the wire because it literally seeing the traffic and offloading very early. A company like Saguna is having this model. Another model is S gateway local breakout. Companies like Atonet, it's one of our partners, again, in a telecom infra project. They're looking to that sort of implementation. Research work on more closely related to 3GPP standards are having a different path, investigating early adopters to this technology. For example, 3GPP CAPS is supported by Cisco at the moment and some other companies. In essence, traffic offload function, how actually edge node works, and APIs is a key focus for the current research work, and BT, as I said, is playing very active role in understanding benefits and issues, and all this with the end goal to help network operator to find industrial strength solution for supporting future services. So therefore, by deploying edge cloud compute solutions with appropriate technology, operator will be able to ensure that 5G network deliver the right solution to customer. To wrap up, there is a number of well-known benefits that edge cloud compute offers to network operator and the whole market, and in terms of enabling disruptive vertical services. This brand new services are attractive at the early stage, at the first step, probably in the enterprise market, with the promise, of improving mobile user quality of experience, reduce volume to traffic to core, having infrastructure efficiency that you can deploy edge cloud in a virtualized environment when it's needed on very dynamic way and where is needed, and also it provides a potential path for software only upgrade to 5G UPF once those solutions come to market. Also, it enables new charging mechanism. This is another area that BT is doing some research work, how to provide some dynamic pricing for edge cloud compute based on demand and supply and so on. However, and this is a bit from my personal experience working last year or a bit more on edge leading work, research work on edge cloud compute in BT, there are issues and challenges, of course. By definition, for example, by definition, edge cloud is a small scale data center placed strategically at the edge of the network. But having the limited hardware resources, this is not like in big data centers when you don't care about how much CPU or storage you have because you have it plenty. At the edge node, you might not have it. So the risks of inefficient application execution is quite visible. Every application developer, selfishly and rightfully so, will try, to grab as much resources of the edge node as possible in order for their application perform the best way possible. However, those applications will need to share resources like CPU or network interfaces or memory and so on. And one application will affect another. So there are risks associated to how you design and onboard those VNFs. Service continuity and mobility between edge nodes is also in development. In today's world of security and security attacks and risk to security, BT is paying very strong attention to security. So having a number of additional small-scale servers remotely located in a network may pose a security risk in terms of software updates and patches if it is not done properly. So from day one, security plays a very important role. Emerging markets for consumer market is everyone understands the value, for example, gaming platform and things like that, but it's unproven business justification at the moment for that. So all the lessons that we're going to learn from the enterprise market and probably early adopters will probably be implemented and to support consumer market, at which point with the sheer numbers that the cost will go down and that will enable network operator to provide ultra reliable low latency services in a much more cost effective way. The difference is in these technical solutions and supporting APIs, especially APIs, is important, and BT is actively working with a worldwide consortias in somehow converging those APIs into a single standard. And even though that single standard might never appear to be a single, at least they will complement each other rather than compete each other. And each of these consortia that I mentioned earlier, they have clear intention to work together for the end goal to have APIs that are fit for purpose to use by application developers and the network operator. So by this, I will conclude my presentation. Thank you.
Thank you, Milan. And let me go back and show you my screen. So we're going to have some Q&A now, and I have a list of questions that have come in. If you have more, feel free to add. We're going to try to go through as many as possible, and if we have some that if you have an answer, we'll try to get back to you later. The slides will be available offline. I see a bunch of you asked them, and you can also listen to the webinar offline. So the first question is, 1 millisecond latency is end-to-end and including all the processing done by the nodes, or is the only on-air in latency? And the answer is it's only on-air. Milan, do you want to add anything to that?
Well, a promise of 1 millisecond is yet to be seen, even on radio. The promise of 5G radio is such that will be improved radio interface comparing to 4G radio. So there are a lot of early research work in BT that are seeing this sort of latency, but we are still waiting to see what industrial solution for 5G radio will be in the future.
Yeah, well, and I guess that again, that's the theoretical in-lab latency. Then in the real world doesn't mean that all 5G RAN is going to be at 1 millisecond, even if that's what you see in the lab, right?
Exactly. This is very much perfect conditions in a lab. Yeah. Trying to see the limits.
Yeah. Now, Milan, that's a question, I guess, for you. Is any Mac server commercially available today?
Well, yes, they are. Yeah, it's a quick question. For example, through TIP work, we are working with companies like Saguna and Atonet, and they have commercially available solutions. Now it all depends. What do you mean by Mac, and even definition of the Mac? It's fairly complicated. So as I said, it all depends on the definitions. Solutions are available commercially.
Yeah, and I guess it is actually true. And let me ask you a question that is related here, because it seemed like an easy question to answer yes or no, but because it's not a 3GPP standard. I mean, when you have a 3GPP standard, it's either meets the requirements or not. But here there's a lot of more fluctuations, and there's so many initiatives around edge computing, and you did an excellent job at explaining how they relate to each other and what they are. But could it be the case that you end up with a situation where you have so much stuff is going on, so many initiatives, which is a good sign, but at the same time, it's also, could we have a fragmentation? So could we have different initiatives with overlapping, with an overlapping scope that instead of working together, they work against each other?
But I think you're right. At the moment, it's fairly complex, fragmented. But BT and other network operators together, and again, this is one of the objectives through the TIP work. This telecom infrastructure project is for the network operator have a direct access and share information with the vendors in some open forum environment. So we all hopefully reach some converging points and consensus on what APIs platforms should support in terms of supporting application developers from one side and network operator for orchestration from another side. So even though it might not be one solution fits all, but that also can be a healthy environment, if there is a competing solutions. But in terms of converging these APIs, all initiatives, although there are many, they're all having a good intention to say we're not going to reinvent the wheel. So if some APIs exist in Etsy, for example, or in Cord, for example, we're not going to look into that, but we are looking into the area that no one looked at before. So we are contributing with a new set of APIs that eventually might come up on one umbrella, under one standard.
Next question is, do you believe that containers more than VMs will be an important component to deploy functions at the edge?
Well, yes. I mean, this all depends on the implementation of what application you want, and so there are many dependencies here. But having containers with already preloaded, a lot of lower layer elements there allows you to very quickly deploy application, for example. But for some application that could be very important, for some others may not be. So yeah, it's clear advantages of what containers offers, and they will be used appropriately for application that requires those functions.
Yeah, and I guess flexibility here, it's key. You need to do whatever it takes to support the applications you want to run. So that's in general crucial. The next question, I'm just going quickly through them. Is there any standardization of handling application communication at the edge across operators, for instance, for autonomous driving?
Well, as I mentioned, there is Etsy Mac, for example, APIs that do offer some sort of APIs that are related for life cycle of and out of VNFs. This specific question for if I understood well, for some VNFs talking to each other, I believe it's down to implementation of that solution. APIs are used there for specific purposes, but there is a lot of network design there for if you want to provide solution that will reuse many VNFs. They're all hosted on the same platform.
Yeah, well, and I guess that when it comes to autonomous driving, if it's truly autonomous, then there is going to be a regulatory aspect, which is very important. You can't just decide you turn it on and you let your car go. You need to have so it's more than just standardization like what we're used to in telecoms. It's going to be a lot of regulation, which is not spectrum regulation, it's regulation of how can you make sure that there is the safety and all that, which I guess is not really a wireless issue, but to some extent it is, right? Okay, let's move on to the next question. So who will build, manage, and operate the edge cloud? Will it be the MNOs, for instance, BTE, or other service providers, or the enterprise? So I think, so let me answer from the analyst point of view, and then I'll ask Milan to continue. Well, I think that this opens a lot of opportunities for different parties to be involved. And so, you know, because you will have multiple edges, you might have different edges, not only for different services, but for different players. So you can imagine that if you are an enterprise and you're doing some automation within your enterprise, it makes sense that the enterprise will manage, will, if anything else, will pay for it and build and manage, at least to some extent. It doesn't mean that the enterprise has to do it, but there might be a lot of relationship where they control it and then they have an operator support it. When I talk to the enterprise, the key concern with this kind of applications is control, the ability to control, the ability to have transparency. And that's exactly what an edge infrastructure brings to them. And that's very valuable. Now, they also, at the same time, they do not want to be necessarily, or they don't want to run it themselves because that's not their core competency. So they're looking for either an operator, a neutral host, or a system integrator, or somebody else that is going to do it for them. But at the same time, this opens the new possibilities in terms of business model, and also new opportunities to use the edge computing infrastructure to manage not only their cellular networks, but also their Wi-Fi or other wireless networks that they might have within their premises. So there is a lot more opportunities in terms of how to do it. And that's the flexibility that this model allows, is to decide, depending on the applications, depending on the enterprise maturity and need and the requirements, to do different things. Now, Milan, what do you think?
I totally agree with you, and I believe this is opening opportunities for many people. By definition, edge cloud node should be fairly easy to deploy and in a dynamic way. So yeah, I can imagine in the future a lot of companies will address enterprise market with some customized solution, and then come back to mobile network operator in order to simply integrate or provide a true connectivity with the network. So this convergence between MNOs and enterprise-focused companies, I believe that will happen.
Okay, now let's move on to network slicing. Will Edge use network slicing for URLLC?
Well, that's a very interesting question. You know, network slicing and Edge will, in many cases, will have to work, together. For example, if you are providing a service from the edge and you want to provide a network slicing on the top of it, that slice will push through the edge anyway. So this opens up opportunity for converged services that will look network slicing from the edge deliberately, or targeting edge cloud as a part of the network slice as a service.
Okay. Yes. Okay. So I'm sorry, I'm looking through that. Now, can you elaborate a bit if we need to apply machine learning or AI in the network to select edge side content dynamically? And so let me try to answer, and I'll ask Milan to contribute more. Yes, that's really that's one of the good examples of the use of machine learning and AI, because if you want to select what is the site, and that might change depending on, for instance, the time of the day, depending on the use demands on the network. So, and latency is one consideration, but it's not all. So if you have, for instance, an application that requires extremely low latency below 1 millisecond, you want to keep everything as close to the edge as possible. But let's say you have an application that it's still requires low latency, but it's not as crucial, and so you can move the function processing a little bit to a more remote site. You might want to do it. You might want to do it, for instance, for cost functions for like power consumption, or because at different times you use different applications in different places and they need a different type of distribution. It's very difficult, however, to do it manually or to do it in a sort of to decide ahead of time. And that's where ML or AI can contribute, because they allow you to learn from past experience if you have a closed loop learning, so that you keep learning and you keep perfecting and refining your system, so that you can do resource allocation in a dynamic way and be more efficient than if you have a fixed infrastructure that somebody has to to set. So there is a lot of opportunity to do that, especially as we were both talking before. You need to manage all sorts of applications concurrently, and you have to take care of network conditions. So trying to sort them out, it's a huge advantage. Milan, do you want to say something about that?
I can just add, from personal experience, because I'm working in a research environment for the last 2 years. There is a huge amount of work in BT, and I'm sure in other, network operators, looking into this sort of artificial intelligence in Mac in terms of service discovery, load balancing, mobility between edge, finding optimum paths for specific users, for specific applications, and so on. This research work is ongoing, and I don't believe there is a it is fairly new technology, and I think at the moment the research work contributes a lot in finding solutions that eventually will become industrial strength solution in an operator network.
Okay, I think we should. I'm going to ask you a different question. I'm sort of going through all the questions that we have not answered, and I see that there is a constant theme there, which is the role of 3GPP. Is 3GPP standardization concluded? What's your view on the standards? Can you give us a little bit of an update of where we are with the 3GPP? And is MEC considered to be part of the 3GPP standard? What's the relationship between MEC and 3GPP?
Well, 3GPP standard, that should be a webinar on itself.
Yes, I know. So it's a little bit unfair here, but maybe you can give a quick...
Very quickly, edge computing is part of 5G architecture, even in release 15. So that is a huge encouragement for edge cloud topic. So this distributed UPF function is included there. We are waiting now to see from vendors implementation how that will gonna look like, and then do research work and test. And I'm sure a lot of research work is already being done in network operators with vendors. So to answer, yes, edge compute is included in 3GPP release 15.
Perfect. I think we're after hours, so I would like to thank you all for attending the webinar. Milan, thanks for being with us, and Mona, I'll hand it back to you.
Thank you.